let's talk about network load balancers, or NLBs. A network load balancer balances TCP, UDP, and TLS traffic. An NLB works at the fourth layer of the OSI, which is the transport layer. Protocols such as TCP and UDP operate at the fourth layer of the OSI. Therefore, the network load balancer can forward traffic using these protocols. Network load balancer listeners support TCP, UDP, and TLS. So, it can load balance incoming connections using these protocols. You can also load balance TCP and UDP connections on this same port number. This is useful for load balancing protocols such as DNS or domain name system that use both TCP and UDP on the same port number. A network load balancer can handle millions of requests per second and has low latency. It also supports SSL offloading. Thus, this CPU-intensive task of decrypting HTTPS and SSL connections can be handled by the network load balancer. It can also provide a static IP address per availability zone, and this is done automatically. So, when you create a network load balancer, AWS automatically assigns a static IP address in each availability zone. These IP addresses do not change during the life of the NLB, thus providing a reliable way for applications and users to connect to your application. It also supports one elastic IP address per availability zone, providing a fixed IP address for your applications. So, regardless of changes to your infrastructure or the EC2 instances behind your NLB, your applications can always reach your NLB using the EIPs. So, unlike the first example about static IPs by AZs, in this case, the EIPs or elastic IP are fixed IP addresses that you request and manage. You can assign and unassign EIPs to resources as needed, which gives you more control over your application's IP addresses. Basically, the difference lies in who manages the IP address, AWS in the first case, and you in the second. So, these are the important features of the network load balancer. The important thing here is that it works at the fourth layer of the OSI model, so it can be used for load balancing using transport layer protocols such as TCP and UDP. Therefore, in the next class, we will understand the configuration scenario and implement a network load balancer.